In this module 4, we will be continuation with electrical circuits and going a little bit deeper. So in this section, this is part 2, and is going into Kirchhoff's law. And basically, it's just things that we covered already, but we're going to be looking at Kirchhoff's laws concerning current and voltage. Now, here's the simplest thing, is that things will always equal. What is ever coming in will be same thing leaving. And whatever power source or current flow, it will always add up to be the same thing. So Kirchhoff's law states that at any point in a circuit, the total current entering that point must equal the total current leaving that point. So there's nothing adding or subtracting or losing. Matter of fact, in engineering and science and physics, it's like the laws of thermodynamics is that we cannot create or destroy energy. Whatever is there is there. And so, in other words, yes, we feel like we lose maybe heat energy or electrical energy, but no, it has been consumed someplace. So, Kirchhoff's current law is the basis of any practical parallel or series circuits, and when we're looking at the current flow through. So in this combination circuits is that very simply, we can see that it starts out with a certain amount of current, but when it comes back, it may be divided up between the different branches and different loads. But when it all comes back, it will always equal what left it, and what is entering back in again. So again, we can see as we go through this circuit, just looking at current, so we can add them up and subtract the total from what each branch lines, it will equal 0. So we can see it here is that we take these resistance, and this is the total. If we subtract all the resistance from the total, it will always equals 0. Okay, Kirchhoff's voltage law states that the algebraic sums of all the potential differences. Remember, the potential difference is the difference of the power coming in and leaving in the power source. So in other words, if you can use algebraic sum of all the potential difference in a closed loop is equal to 0 again. So again, we can take each one of these and know the total voltage will equal the voltage at each one of these. It will always equal 0. A closed loop, open loop. So any closed path for current flow is called a loop. A loop equation simplifies the voltage around the loop. So again, we could take the power coming in and then, which is the total, and separate and subtract each one of the branch lines, it will always equal 0 again. Again, we can see on the schematic and look at the voltage, look at the current, look at the resistance, and it always will balance. So applying Kirchhoff's voltage laws, and again, this is a series circuit, and we could add up each of the individual voltage drops based on the current, and we can always know what it is. The difference is now we have two power supplies. We have one here and one there. So again, we can know what the voltage, each one of these, we can determine what the voltage on the other side is. Okay, so if we look at that, we got 3 volts, we have 2 volts, and you have 6 volts. So 3, 5, 11, we got 15. So this must be 4. And this mathematically will show exactly what it is. Okay, Kirchhoff's current law is the statement that the total amount of current flowing through a parallel circuit is equal to the sum of the amounts of the current flowing through each current path. And Kirchhoff's voltage law says the statement that the sum of all the voltage drops in the circuit is equal to the source voltage of the circuit. And that's pretty much it. So we got make sure you read through the chapter. Who stated that the current entering at the point must equal the total current leaving that point? And of course, we just talked about it, and it is definitely Kirchhoff. In a circuit with an applied voltage of 10 volts and voltage drop of which equals voltage 1 equals voltage of 2 volts, then in 2 5 volts, and 3 will be what? Okay, we got 2, we got 5. So the answer, basically subtract the difference, and we should have that answer, which is 3. And that's the end of module 4.